Good morning. Electric motors have been a part of our everyday routines, although not readily apparent. This is because they are inside the appliances, vehicles, and different technologies that we make use of in order to make our lives more convenient and specifically less strenuous. They convert electrical energy into useful mechanical energy that we can then transmit to a variety of different devices. A current carrying a wire will experience a force when exposed to a magnetic field. This is properly referred to as the motor effect. Now remember, the direction of the force depends upon the magnetic field and the current. This is given by Fleming's left-hand rule. Now remember, this is not to be confused with the right-hand rule, which is used for electric generators, which has the opposite function as an electric motor. Now Fleming's left-hand rule states that the thumb represents the force or the direction of the force, thrust, or motion. The forefinger or index finger represents the magnetic field, and the middle finger now represents the direction of the electric current. As may be seen in this animation, the forces applied to the coil will tend to make it rotate in a clockwise direction. However, when it has finished rotating in 180 degrees, its direction will noticeably change. Due to the inverted directions of the force on either side, it is unable to rotate for an entire 360 degrees, which isn't entirely useful for us since most forces that may be found that can be harnessed or conversely transferred energy to are rotating in 360 degrees, examples of which can be seen on the screen right now. In order to solve this, engineers incorporated a relatively simple device called a split ring commutator, which enables the electrical sources to be stationary. This means that the negative terminal and positive terminal, keep catching my tongue, will stay put in their respective positions during the entire process, effectively enabling rotations of 360 degrees. Now, normal everyday work of any average person is physically demanding. Therefore, we need a substantially more powerful machine. To buff up our electric motor, we can do any of the three in the following. Number 1. Increase the electrical current. This may pertain to the voltage or the ampere rating of the electricity, which by the way is also termed as amperage. Number 2. Add more turns to the coil. This is done so that there may be more surface area for intersections in the magnetic flux of the magnets and the electric field of the coils. In this increase of interactions, the forces are affected in a direct proportion. And lastly, for number 3, integrate stronger magnets into the system. Number 3, using stronger magnets simply means that it will push harder on the field around it, and everything follows. Thank you.